In this paper, we present our HandBooster, a new approach to uplift the data diversity and boost the 3D hand mesh reconstruction performance. First, we designed the novel condition creator to effectively produce realistic and diverse grasping poses. Then, we use content-aware conditions to generate realistic images with diverse hand appearances, backgrounds, and accurate annotations. Finally, our generated data is used to train several models to improve their performance. Extensive experiments show our significant improvements on different baselines. Single-image 3D hand mesh reconstruction is very challenging. To achieve strong performance and well generalizability, large-scale and diverse datasets with accurate annotations are necessary. The lab-captured dataset has realistic appearances and accurate annotations. However, constructing the mocap system is expensive and it lacks grasping pose and background diversities. Though the in-the-wild dataset provides both diverse and realistic samples, its annotation quality is not guaranteed. Synthetic data is a workaround, but the rendered appearances and backgrounds are unrealistic. Existing hand-object image synthesis methods are rendering-based and generative-based, however, the former lacks realism and the latter lacks diversity. This motivates us to generate realistic cases with diverse appearances, poses, views, and backgrounds. Given the training data, there are several learning-based reconstruction methods. Most of them focus on algorithmic designs. Our method is agnostic to them and can boost their performance by improving the data diversity. Our framework includes 3 stages. First, we design the novel condition creator, where real-world poses are randomly rotated to produce novel views. To handle unseen scenarios, we also generate novel poses by performing grasping simulations. To maximize its efficacy, we construct the pose vector to compute the pose similarity. Then, our intra-distribution sampling strategy is applied to existing and novel poses separately to find distinct ones. After that, existing and novel poses are combined using our cross-distribution strategy to yield a more balanced distribution. Given hand-object interaction poses, we design the diffusion-based synthesizer to generate corresponding RGB images. We use the normal and texture conditions as they preserve more geometric and semantic information. We also design the weighted MSE loss and the edge cases filtering process to ensure the quality of the generated samples. Finally, the generated data are used to train different reconstruction models to improve their performance. We conduct experiments on several benchmarks. First, we show the quantitative results on DEX-Y-CBS0 split. Our method consistently boosts all 3 baselines on all metrics. Besides, we also test on the more challenging S1 split, which contains unseen subjects. Our HandBooster still consistently improves all baselines significantly. We perform the same experiments on HO3D. It is clear that all baselines consistently achieve improved precision when boosted by our generated data, showing the great effectiveness and robustness of our method. We also plot the mesh PCK, AUC curves. The line after applying our method is always on above. Here we show the qualitative comparison. Benefiting from our diverse and novel samples, all baselines can produce plausible results even under severe occlusions. We provide some generated cases to show the novelty and diversity of our generated data on hand appearance, camera view, and background. Here we conduct detailed ablation studies. Comparing rows AB and AG, training with the rendering-based data brings limited improvement, while our HandBooster boosts the performance by a large margin. Comparing rows C to F, using the normal and texture maps is better than other 2D representations. Comparing rows H to K, L to O, and P to S, we can see that all our major components are effective for different baselines. For randomly chosen synthetic poses, we retrieve the most similar pose within the same object category in the real-world data. It shows that we can produce novel poses. Further, we perform similar retrieving on generated images. Their obvious differences demonstrate our capability to generate novel and diverse hand appearances and backgrounds. Here are all the references in this presentation. Thank you for watching.